You are HOD of Physics, SNS College of Engineering. Today I discuss the topic of case study on crystal structure and its applications. The case study on crystal structure and its application. But I will show for you in ultrasonic interferometer. Right? Do you know that what is ultrasound? Ultrasound?
It's a sound wave.
It's a sound wave. That is the application of ultrasound. Yeah, greater than 20,000 Hz. It's audible or inaudible? Inaudible. It's inaudible. Right, very good. So it's an inaudible range of sound wave is created inside of it. We use in one oscillator, right? That is a piezoelectric oscillator.
So what is piezoelectric oscillator?
The piezoelectric oscillator, it's an effect of piezoelectric effect, right? That means the piezoelectric crystal will be forming inside of the oscillator, right? Oh, piezoelectric oscillator working, the piezoelectric crystal to give an electric field, the crystal become vibrating. That vibration we call is a sound wave. That wave called is a ultrasound, right? Then the piezoelectric means we take a quartz crystals, right? The quartz crystal, the top and bottom, it's a form of pyramid structure. Pyramid, you know that it's a triangle, right? The center is cylindrical. The top and bottom is a, what is that? Is a pyramid structure, right? So it's look like in a sharp crystals. So the sharp crystal to be existed in the charges very easy and vibration also, right? All the crystal is made up of in a quartz material, right? So the piezoelectric crystal is forming inside of that. Then why we used in this piezoelectric crystal means the other types of crystal is not a natural charges, right? In some of the crystal is formed naturally charged crystals. For example, quartz. So the quartz is one of the best example of naturally charged crystal. So the charged crystal already could be formed, right? So the piezoelectric crystal to vibrate the ultrasound is produced, right? We fill in water from here. This is a chamber, right? The optical fiber is connected in chamber, right? The top is connected in perimeter. That means look like the screw watch. So you turn in clockwise or anti-clockwise. The piston will be moved from inside of the water. This is a hollow cylinder. The hollow cylinder we fill in 3/4 of water. So we have used in another one case study of this devices also. We have comparing different types of liquids compressibility. We take a water, right? We find from the compressibility of water. You take a kerosene, we find the kerosene. You take in alcohol, right? So the initially we find from the wavelength and velocity of what is that? Ultrasonic, right? The device name is ultrasonic interferometer, but we find what is that? Ultrasound wavelength and velocity. The both we have calculated, right? Then the compressibility we have find it. Okay, right. So the piezoelectric we use it from here. Why we taken from this experiment to explain from crystal structure means the structure of the piezoelectric is very important. Right? Already we discussed in previous topic, right? The 7 types of crystals, right? So the crystal structure based the axis, the angle and the output of the crystals. This is very important. That means atomic packing factor, right? So here the piezoelectric crystal structure is very important. Do you understand? So that why I am taken from this ultrasounds to explain our crystals. Right? Any doubt?
What is the correlation between ultrasonic interferometer?
Crystal. That why I am telling that. We take a one crystal, right? It's a naturally charged crystal or unnaturally charged crystal, we have found exact thickness and breadth of the crystals, right? It's very difficult to form of ultrasound from this piezoelectric oscillator means, right, the shape of the piezoelectric crystal. I am telling one circular, then top and bottom is in a pyramid structure. That is very difficult to form out the structure. You take a cubical, is very simple, right? You take a hexagonal, is very simple, 6 faces. But this is, it's a very difficult. One center is a circle and top is a pyramid structure, right? This all to form in one structure, that is a difficult. So that difficult to form in the output of ultrasound. That is a combination of ultrasound and the crystal structure, right? So the crystal structure we used in many different formations in different applications, right? That we discussed in another one topic, right? Thank you very much. We discussed in another one topic in another one, right? Thank you.